welcome to the fifth module, which is blockchain implementation of this course, Blockchain for Finance Professionals. In this module, which will understand about blockchain financial system, blockchain for supply chain provenance, asset keep in blockchain, blockchain for multi-party systems. And in this session, we'll discuss about blockchain as a financial system. So this is in module 5. We are going to understand blockchain implementation. Let us go in deep dive to see some of the use cases, how blockchain is important in the financial world. We'll be covering a couple of the top use cases that's used in the financial world. So let's understand in this section as blockchain as a financial system, because this is going to rampantly change the way the business is going to get done in the future. So it is important to understand how blockchain can act as a financial system. So it started like 1994. It was a bad year for banking because kind of internet era came in, and then fintech was not that responsive in those years. But then times have changed now. In mid 2000s, fintech attacked the banks. They came out with every small thing in head on, be it small things in terms of how do you buy, to lend, to anything and everything. So you can see the aura of entire fintech companies that came in early 2000s. And actually in 2014 there was not much plan about blockchain, but then you can see other things. But focus in 2015 has been completely changed. Actually they had planned to do other priorities, including cybersecurity, balance sheet efficiency, payments transformation, compliance, data management and all. But then suddenly it's now blockchain. That's the new internet, and it's becoming the whole end-to-end in financial world. So basically, but the outcomes are good for banks, right? Blockchain is helpful. It is like early stage banks, because you had IT has given some savings when technology started going. Similarly, blockchain will bring in cost savings. You have seen already some of the numbers when you migrate to a blockchain. It almost cuts the intermediaries. So basically, what is the deep dive in the explaining blockchain is basically decentralization, disintermediation, and distributed ledgers, and it's programmable assets, right? So it's assets, trust, ownership, money, identity, and contract. So it's basically atomic DD dive. So it's programmable. Second, it's based on decentralization, and third, it's kind of affecting governance value creation. So basically, in a single statement, what we can say is exchanging assets without any central intermediaries. And it touches the core of banking, right? And it's a challenge. So just want to explain that, it's atomic deep dive, in explaining the blockchain. So consumers ask why, because there are a lot of dependencies, right? When it comes to settlements or authorizations, depositing a check, we typically have to wait for long days before confirming confirmations, right? So this is what it will happen with blockchain. So you typically cut down the entire, this is almost like real time. On the left extreme side, you have the basically importer who wants to send goods to the exporter. And you can see that, the importer has initiated the transfer between exporter to importer. And you can see the goods delivery, how it happens, and how the smart terms settlement happens on the right hand side. So it's very easy. The exporter initiates the shipment, verified goods, product shipped, received goods, goes through a smart contract, shipment received, and export bank, and payment complete with import bank. So there's a financial agreement, very simple, importer exporter. There is a smart contract. It's kind of a financial agreement, and the export import bank agrees to certain payments, and then it's almost like real time. So this is how fast it is. Earlier, current system is you have intermediaries, you have some of them are physical documents, so you need to verify. But here it is just simple, all smart contracts. Whether you exporter to customs to fight, or another importer customs, whatever it is, it's all all shipments, it's all letter of credit, everything is like smart contract. So it's a simple line of code. So it's like financial services workflow, it's a very important thing, and it's almost like real time. In trade finance, it's important because why you need to set up chain in the trade finance, because it gives you real time review and approval. It is transparent factoring, right? Because you have invoices accessed on DLT enabled, transparent and real time. Ownership proof, who's the ownership and where is the location of goods. It gives you transparency and reduces counterparty risk, because bill of landing is the most crucial one, and this eliminates the chance of double spending. Somebody has paid away, so corruption comes down here. disintermediation, because there is no need of intermediary. This, like, you can just have an importer bank to an exporter bank, and you can just transfer the cash. And it's decentralized contract negotiation, because what happens is, as soon as the contract terms are met, then distributor ledger in real time this efficiently monitor the goods delivery and reduces transaction fee. Like as I said, contract terms are very simple and executed through smart contracts, so it eliminates the need for additional transaction fee for verifying and all those things. So essentially, there are 7 to 8 benefits, and this is one of the biggest use case in trade finance. And if you see the relationship, right, banks and fintech has been always going on hand to hand together. Like banks like Citibank, JP Morgan, all of them have actually funded startups to create products, and then they're being close to them, and it's like a symbiotic relationship. And they invest in ecosystems accelerators so that they can just absorb the company, and then they can use it internally, and then probably use it for their customers as well. So it's a symbiotic relationship. Basically, there is a common dilemma, but then the reality is that they seem to be survived. So there is an asset movement. If you see on the left hand side, bank A, bank B, bank C, bank D, and bank E, there are so many. It's like a circulatory world. It keeps going from bank A to bank B. There are so many permutation and combination. Whereas if you just see on the right hand side in the distributed ledger, it is like straight arrows. There is not much crisscrossing, because all belong to the same ledger, same blockchain. It's easy. So, but they feel that perceived techs are real, but actually no. Tech companies, global banks perceive threat for industry disruption, because tech companies have to. The first use case comes from fintech, so there's a lot of investment that goes. But then this is just statistics. So, how does blockchain and established methods? How does it like retrofit, or how does it going to replace or anything? Blockchain such as clearing houses and private exchange networks like Swift are like oil and water. They will not mix well, because one is centralized intermediary, other one is no intermediary, peer-to-peer trust. So basically, it will be like how the banks will retrofit the blockchain will be challenging. But then let's wait and watch how the entire thing is changing, because Swift you have to pay a huge commission, whereas in blockchain, like if you have to use Ripple, it's just 0.001 transaction percent of the transaction fee. Yeah, we can have that. Having the blockchain without Bitcoin, it's like a knee-jerk reaction. But then that is the first use case of blockchain. So without Bitcoin is a valid construct, but then actually if Bitcoin is becoming more and more acceptable, so and I think it is a backbone for blockchain. So let's understand what are the blockchain capabilities of financial services. The key attributes is it contains a secure electronic timestamp transaction ledger database that is shared by all parties in a distributed network. First, understand that. That means it is secure electronic timestamp. Second, it has a massive ledger of transaction verified by a global network of computers. And it is identical copies of the ledger are maintained in multiple systems controlled by different entities. Very important. Then it's based on the cryptographic peer-to-peer network. So these are some of the challenges, right, for blockchain, for financial services. So cryptography, security. So blockchain brings that. It assures immutability and irreversibility. So someone can tell about what is immutability. Basically, you cannot reverse a record. That's the biggest advantage of blockchain. And once entered, it cannot be erased, and it has multiple copies. And the third thing is like it can be public, private, or permissioned or unpermissioned. We have seen public blockchain example is Bitcoin or Ethereum. Permission means like Hyperledger, and it comprises of any transaction which is verified, and any malfunction record will be thrown out of the blockchain. So you have seen that also using the hash functions. So it also allows participants to review the blockchain entry. So anyone can look at it. If it's a private blockchain, you will know who are the actors. It's basically, it works on the virtual currency securities and all. So you can also understand the record transaction without exactly exposing the details. Yeah, this might be required for something like anonymity, but then it might be one of the use case. It actually enables real-time settlement. That's the fastest thing. You can actually, last thing is you can actually set business rules. You can enable smart contracts, and in the computer language that can be automatically executed. So you don't need a human interface at all. So you have a lot of advantages, and each one of the advantages is actually a challenge for financial companies or banks. So if you see potential uses in financial systems, commercial banking, you have cryptocurrency denominated products, and you have asset and real-time real estate tracking. You have a physical banking marketplace, syndicate lending, you have real-time loan funding, you have use case of personal financial management, you have liquidity management, cash reserve management and interbank settlements, and you have even customer acquisition and loyalty management. So you have so much of potential users in the financial service domain. And if you take the trade and real supply chain, it includes debt servicing, insurance, factoring. That's why important in terms of LOCs, that is line of credit, letter of credit. Sorry, and receivables financing is very important. If it's real time, you can cut down on the lot of inventory based financing, decentralized contracts, document preparation, and it also increases the interaction between export and import banks, eliminating the role of corresponding bank. You can actually directly correlate, So you have so much of use cases coming in financial systems. Then in terms of payments, you have micro payments, retail payments, wholesale payments, P2P payments processing, exchange services, offerings, currency exchange, cross-border remittance, and so on and so forth. So you have a whole lot of things in payments. Then in terms of capital markets, you have clearing and settlement, hyperledger. Usually it's the biggest use case. Post-trade reconciliation, derivatives transaction, asset documentation, name it, right? It's all happening in payments, capital markets, commercial banking, trade and supply chain, trade and financial supply chain. And risk management, you can do a lot of counterparty risk, fraud risk management can be reduced, liquidity risk management, operational risk improvement. So there's so many things happening in the risk management area. And also in regulatory compliance, right? It actually automates the whole compliance. It also increases, like you have seen that AML KYC, like anti-money laundering KYC. So in India, there is a conglomeration of at least like 35-40 banks who are coming out with the common KYC. It's a tool for regulators, and it's also a regulatory reporting automation. So you can understand, right? So many use cases in financial systems. So these are some of the organizations that is embracing blockchain. R3CO, which is used by Credit Suisse, Royal Bank of Scotland, Bank of America, then DTCC, which is one of the biggest clearing corporations. They have been in partnership with IBM, then UBS. They have got Innovation Lab, Barclays. They are trying to work with a Israeli startup. So these are a bit old, but then Nasdaq has started with open asset protocols for the private platform. So you're seeing like who's of financial organizations starting embracing blockchain. So they're just not, they're doing proof of concept. Some of them are live also, but actually you will see the potential benefits, but at least you can see POCs to understand what are the, narrow down the committed projects, once you get the POC, then at least it goes up to scale up concept. So again, we have seen this already. And then not only this, right, you have regulators working on the regulators and policymakers, right? You have European Commission, you have International Monetary Fund, you have BankFin, Sweden's Central Bank, New York Financial Services Department, Swedish Authority, US Federal Reserve. They are working with IBM to form a new digital system. IMF is actually working on a huge regulatory framework, which actually gives you in the international monetary, European Commission, they are working on anti-money laundering directive. Sweden Central Bank, they introduced digital currency to support the country's cash. New York, they have bit license regulation. So if you see, like, government financial agencies are also working on the policy making and, on the elaboration that on each and every use case and business cases. And it's also easy, right? You can actually see implementation of blockchains in new segments without internal integration. Insight, like, you don't have to start it as a baggage, but then you can actually currently transform the whole system that you're looking to 18 to 24 months for full implementation. So without even disturbing the existing methods, you can just easily transform with the caveat, in terms of training and, proper cycle without containing this as a baggage. You can actually integrate into the existing systems. There are some lot of consultancies that's available. They help you re-engineer, change, and implement large projects. Like I am an external consultant, so I help some of the financial organizations earlier. I have been helping. I'll be continuing to help. And basically, you need to, if you're an external or if you're an enterprise, you just have to understand the blockchain capabilities. And the other external consultants can take care of entire, running your experiments rather than you can just concentrate on your business. Everything else can be like, done through external consultancies. So blockchain also is like running to capital markets. You have major consortia, R3Serve and Linux Foundation. So we have seen like it has started making a dent in capital markets, but this kind of accepted, rejected, we'll have to wait and watch. And there are many pivots IT-bit, trade blockchain pivots, and so on and so forth. It's all in the proof of concept, or some of them have already gone live. So there are high venture capital valuations. These are large bets. The capital markets is one of the most large valuations, and every early stage startups are getting funding, and basically VCs and private equity investors are going so that they don't miss out the huge venture capital investment for right startup. So we understood high level on how blockchain happens in a financial world and how it has been taken care by governmental agencies, banks, implementation, and what some of the use cases on deep dive of it in this entire. I hope you get a good overview on blockchain financial system after completing this session. Next, we will know more about blockchain for provenance tracking. Thank you. Welcome to this session. Here we will discuss about the provenance tracking in blockchain. Let's start then. So in this section, blockchain, let's understand how it is helping provenance tracking, right? Because it's one of the most important thing in trade finance. The current situation is you have huge complexity, right? Errors in manual work, high transaction costs, and also theft. Other things like unsafe working condition, illegal extraction, and so the current situation is in terms of provenance, right? Moving goods from one place to another and tracking it is like costly and unreliable. Not that it's not, it's a foolproof. It's a one of the time tested methodology, but then you can actually correct it with a lot of situation transformation, using digital. So you need a supply chain solution, including finance, that can actually be trustworthy, transparent, and it can help supply chain goods and services on a real time tracking, right? So let's understand how it is. The main question is, can blockchain technology actually improve today's supply chain and logistics? To operational improve efficiencies, fraud, or sometimes grand challenges such as unethical labor practices and environmental degradation? Let's see. So again, go back to the fundamentals, right? You've seen like blockchain technology is adding trust to untrusted environment and actually exploiting a distributed ledger mechanism that is supported by peer-to-peer, and in order to create a record of significant events. That means that you are creating an untrusted environment so that a distributed ledger technology comes in as a technology support, and you are able to do authoritative way of managing things. And from a business point of view, it actually helps in transactions without need for a central arbitrator, right? So you have seen like blockchain is in terms of highest kind of adoption, right? It's in the peak. So if you want to restate the definition, it's going back to the fundamentals, right? So blockchain is actually changing the way the supply chain can get transformed. So if you see like this is the cycle, right? You have a raw material supplied by suppliers, it goes into the manufacturing plant, then distribution, then retail, and then customer. So see the complexity, you see the cycle, right? Manufacturer A, B, C, ship, distributor A, B, and retailer. So this is the current asset movement in supply chain. And if you see, this is kind of getting transformed. And if you really look at it, how much value it actually by 2026, as per the thing, if you take retail and supply chain, it itself is 136 billion. And the 27 billion is already kind of addressable market. That is immediate. So you have a 100 billion market for just supply chain, which is very high. So what are the challenges, right? The challenges are like cooperative and establishing standards, because still there is no de facto standard. Every participant will come out with their own way of adoption. So that's kind of critical mass is not achieved. Only when everybody when everybody comes to the same table, then you will kind of get achieved, right? Then regulatory framework. Not much regulatory framework is available on how blockchain actually can increase in the way that kind of transformation happens, right? Then there is legal framework. Regulatory includes your AML, KYC, local regulation, and so on and so forth. Legal from how trade can actually, if there is an issue, like how can we tackle that? For example, who is responsible if the smart contract goes haywire, right? There is no centralized authority. So how can you give an underlying asset by tokenizing in the distributed ledger with a legal framework? Then scalability, right? You have seen Bitcoin is scalable, but then is there an operational resiliency that can actually scalable? And then settling value in real money. All these days it's been like fiat currencies, right? How do you tokenize those solutions with a payment and settlement in terms of either cryptocurrencies or using smart contracts or whatever it is, right? So these are some of the challenges that's kind of hindering the mainstream adoption of blockchain in at least in supply chain. So blockchain in supply chain, what all it does, it increases the security of transaction. That's definite. Middlemen can be completely avoided, definite. More transparent and auditing can be simplified because anyone can actually view the ledger depending on the use case. Then smart contracts are implemented so that you have a smooth transformation or transportation of goods. And actually, this can actually significantly reduce human errors, transaction costs, and delivery delays. So, what are the things? You have traceability, you have smart contracts, you have transparency, you have process optimization, you have currency, which with including loyalty programs and including IoT integration. For example, I am working with a company which is trying to develop blockchain from farmers to consumers. So it's a kind of agricultural supply chain, including finance. That's I've been working currently in recent times as a consultant. So you see the provenance that's coming through, right? In the entire blockchain. How does it help? So it's also visible to the customer in terms of IoT integration, right? And then it reduces the risk of tampering, fraud. It also gives a lot of value added, right? For example, in one example, we can actually know, like, how to attach like the right fish was caught and when and things like that, right? With supply chain transparency using blockchain. So example here, like you can actually condition from a fishing how it is processed, transport, retail, consumer feedback. So entire transparency supply chain can be actually used using blockchain. So this is just an example of fishing supply chain. How blockchain applications have the potential to improve supply chain using basically for registering, certifying, tracking, and at low cost because two are connected via a supply chain and all goods are identified via tokens. So it is kind of anonymized and each transaction is timestamped and it's in encryption. And smart contracts can be deployed automatically to execute payments and other procedures. So what are the things like how we can do it? You can have an application, decentralized application that helps transform the supply chain market at low cost goods transfer. Then you can actually have a tokenization via blockchain and each transaction is timestamped. And we can deploy smart contracts basically to execute payments and work with the enterprises. So today, this is the system. Tomorrow, you will have all through a blockchain, direct relationship and visibility across a supply chain without a need for intermediary. The left hand side is today, it's a cycle. Tomorrow, it's like a direct relationship. You don't need intermediary. So potential impacts and development, several companies are actually working on testing blockchain for the supply chains. So this is source map. This is one of the systems which is working around some health and safety for supply chain. Mojix, they are trying to automate the supply chain to enable smart contracts. So the developed solution can allow smart contracts between suppliers, retailers, and logistics providers. So we have seen it here, right? So you can actually see today and tomorrow. So Mojix is one of the use case. Then Everledger. Actually, Everledger is a very big case study. So they have a tracking mechanism of diamonds. They actually track from mines to jewelry stores, and they also have insurance, which with documentation. So they take 40 attributes and they generate a serial number for each and every diamond and they've been giving digital IDs to Everledger blockchain. So this makes it establish, maintain ownership, which can help counteract fraud, support police and insurance investigators who are tracking stolen gems. So it's easy to find out, like, each and every step of a diamond thing, starting from cutting to, identification to finally reaching the customer place. It's all done using a digital ID in the blockchain. So it's a very big case study. So Provenance, this is another company which has developed real time that verifies an asset by assigning a token or a digital passport. This company gives you a tool to create living histories for any product. So this is another example. SKU chain, they have cryptographic principles taken from the Bitcoin network. So they are actually making next generation barcodes and RFID tags. So basically the use case is it's like an anti-counterfeiting systems. Not that the current systems is there, but here you can actually verify supply chain all the way from point of consumption, from the manufacturing. So it's a kind of a next generation hologram or copy resistant labels or counterfeiting systems. So they have a cryptographic proof of each origin of SKU, so from the point of consumption. So it's a very important use case. Cargo chain, basically they have trade documents between trade parties international. So again, you have a lot of trading companies and they just help contractual relationships. So cargo chain is doing that use case. Gate chain, they are doing, we have seen that as a trade finance, right? So they are working on electronic documents, smart contracts, payment obligations in a faster and more easier and secure way. So this is another example of trade finance in blockchain. Hijro, this is basically operating financial network. So it's like a bank powered by distributed ledger technology. You can also Google this. This is again one of the famous one. Modem. Though they are actually taking all the data and they are doing their product actually monitors the temperature of the shipment to ensure GDP regulations, and their data is on a smart contract. Actually, it seemed like in Swiss market 95% success rate. So basically, they are doing pharma supply chain, and they are ensuring the temperature of the parcel, especially the drugs like insulins and biologics, to ensure GDP that is as per the FDA regulations or the European regulations, and they are using blockchain and smart contracts. So basically, you have seen like how blockchain can enable supply chain, provenance, trade finance in blockchain, and all and other use cases. And I have run through some of the biggest like Everledger to Modem in this entire discussion. That's it. In the next session, we will talk about how blockchain helps in asset keeping. Thank you. Hello. As we discussed before, we will know about blockchain for asset keeping in this session. So we have seen how blockchain actually helps in the provenance and supply chain finance. Let's understand how it is useful for asset keeping, because this is one of the important things in financial world, asset protection. So what is records management? Basically, it's a information management or records information management, RIM. Basically, you have to manage the life cycle of records, from organization from the time they are created till disposal. With the more and more digitization, it's important to classify, store, secure, retrieve, track, and destroy their permanent records. With regulations like GDPR, you need to have a lot of privacy also and also secure the documents. So digital world. So it's like as I already told, creating and capturing the digital records, securing the digital records, preserving, restriction access, disposing, protection from ransomware and other threats, and also protecting the from unauthorized disclosure, right? Theft or alteration or disclosure. So this is the whole digital world. So, but why do you need a secure records management? The healthcare now leads with the records compromised till date. There's so many breaches that's happened. Like the more than 12 million records have got exposed. And if you say there are 264 incidents, and even government and military sector has got some incidents. So we need a high-end secure records management here. What is characteristics of record management? It should be having assurance. It should sit carefully on the internet. It should not rely on any network security. All data access should be well known, and it should be having a security mode of operation. And it's like a bring your own device kind of atmosphere. So you should have a complete characteristics of records management. It should support industry standard. It should be access to any way via hardware. It should have a mandatory security policy. It should support for industry records management dictionaries. No centralized access control. It's immune to ransomware. So basically, if you say the digital world, right, there is a metadata, right? So you have various kinds of metadata. You have types at least. You have descriptive metadata. You have administrative metadata. You have structural metadata. So descriptive is basically the intellectual content of the resource. That includes like indexing, discovery, and identification. The administrative is like who owns this digital resource, who will be given rights, and things like that. And structural is like basically like relationship between multiple digital files. Like if you have a page order like a library in a digitized book, that is like structural metadata. So there was one project which is called Interpares. This was one of the good record keeping project which I just wanted to quote. It basically has chain of custody and chain of preservation, and basically they're trying to create a long-term preservation of electronic records. So you can Google this. So this is one of the famous project, and this is one of the classic example how this is getting transformed using blockchain. So this is the whole thing. They are basically doing how do asset register asset, and then how do you verify who has the verification. Then the electronic record is accessible by whom, and then there is a privacy issues and who is. So basically, this is a template that they are using. With the system. So you can see some screenshots here, how metadata is being completed. And they also give a certificate of authenticity. So this is kind of used as in terms of, including like for products like Microsoft and like for passports, even for certifications and even for security. So what is the essence is like, I just want to bring, because records management is a big subject, so I just want to cover at least the fundamentals of that. And so it has high cost, it has long delays, it's permission granted, and so it has high cost, it is getting long delays, it is permission granted, and it is trusted third party. So which is all the issues and challenges. And then metadata is a big example. So you have technical metadata, you need to preserve this metadata, and you have a lot of administrative problems. So these are things that is challenged, and you have a properties. It is like atomicity, you have consistency, and you need to store record properly. So what you call it as records management solution should be always immutable. So what happens is like it should be atomicity, like it should have, make sure that the entire transaction is captured. That means like the atomicity in every situation, including power failure, errors or crashes. And it should be indivisible, right? And it should have consistency. So for all of this, RMS should be written once, data stored, and it should be immutable, right? For all operational use cases. And it should be easily to isolate, whenever it's required, and it should be durable across physical, any kind of locations. So it should also be having, it should be free from denial of service and resiliency. So give this. So with all this, we should have a decentralized key management system. It should be useful and support for various use cases, including mobile. And in case of health records, an RMS should be exclusive control and unauthorized access. And it should be like with encryption and globally secure. So this is all possible through blockchain. So that's what we are coming, the blockchain records management. So it is based on blockchain technology. It's completely network stack. It's HSM protected keys, and it comes with cryptographic protocol. So all that last 5 to 7 minutes that what we have seen, what is records management, what are the characteristics, what are the functionalities, what are the challenges, it's all done by what we call it as blockchain records management. So here, it's all parties are sustained, identified via secure identity. So it is a SIN number, and this supports peer-to-peer, any of the encryption, and it enforces key management system, and all records are encrypted at rest, and it's a fail-safe design. That means in a blockchain, if there's any change that is happening, they can easily recognize that, which is kind of giving non-private records. So privacy of records is the most key here, and this is a blockchain-based distributed key management system, and it runs on application datagram protocol. So it can run on any network. You can actually have short packets called datagrams. It operates in a self-contained entity, and it will be delivered to the destination without the reliance on between sources and destination. It's kind of connectionless. You don't need a session management or a special channel or a VPN. It supports stateless datagram encryption via content management syntax, and it has public keys. So this runs on application data protocol. That's a kind of programming. It sits on any network. You have short packets of data called datagrams. It is independent entity carrying capacity. You don't need any connections. It supports stateless datagram encryption via content messaging systems, and it's available, privately owned. You can have managed private cloud. You can also have SDK for client and application, and suitable for PC and mobile. So it gives all of them a lot, a click of a button. So this is one of the blockchain record management system is one of the growing area, and can help financial organizations. And you have data options. You can have unencrypted data. You have encrypted data. You can also have hash data. So that means like you can classify the data. If it's been read by every participant, you can have an unencrypted, which is like still transparent, and it doesn't have to create a resolution in terms of dispute. If it is like encrypted, if you require any encryption, so you can have an encryption point. Some of them, a third party is like you can also have a hash data. That means like a fingerprint data. You can actually hash, right? You understood, right? What is hashing? That means for every input there is a unique output, and this can be placed on the blockchain where you don't even know who are the identities, giving from using hash computation. So that's the beauty about this. So in this, we have understood what is blockchain, how it can be used in records management. We have seen some of the records management and how blockchain record management is different, what the characteristics. So this is again a big use case in financial services. That's all for this session. Next, we'll learn about blockchain for multi-party systems. Thank you. Welcome to this session. We will discuss about blockchain for multi-party systems in this particular session. So let's jump the session. So in this section, we will understand how blockchain is enabled as a multi-party aggregation. In financial world, it's a multi-party system, right? You have a lot of intermediaries, you have a lot of actors, you have a lot of relationship ecosystem. So let's understand how blockchain is trying to solve this as a multi-party aggregation. So basically, let's understand if you have two banks with two internal databases of customer identity verification, and at some point they notice that they share a lot of customers. So there is a reciprocal way of entering a sharing arrangement in which they exchange verification data to avoid duplicate work. So technically, this is called master slave data replication in technical language, in which like you have a live read-only copy of the database and you can run queries in parallel against its own database and the replica. So this is one of the examples of multi-party aggregation. And imagine these two banks invite three others to participate in the circle of sharing. So it's basically each of the five banks runs its own master database along with four replicas of the others. With 5 masters, 20 replicas, we have 25 databases in total. While doable, this consumes a lot of time and resources in each bank's IT department. So what is the essential? 5 masters, 20 replicas, and 25 databases. Fast forward to this point, understand where 20 banks are sharing information. So what is essential is like you're looking at 400 databases instance in total. So for every 100 banks, you reach 10,000 instances. So that means like if every party is sharing with every other party, it is like quadrupled or 8 times, or it is more than 10 times the square of it's like directly proportional to square of number of participants. At some point, it is scalable, but it is bound to break down. So what is this? Blockchain is a good solution for this. One solution is that all the banks will have a trusted intermediary, which will maintain a single master database. For example, if you are using Hyperledger or Ethereum, you can have one replica within four walls, and anybody can get access. So since it's a private ledger, Hyperledger can be one, and so it brings in the value added benefit of redundancy and failover of the system as a whole. So this is what I say. Identity is one of the use cases in banks using blockchain. Second, know your customer. The second, because some banks will have the same customer across. So the only thing is blockchains offer a simple, cheaper alternative with shared databases, multiple copies, and it runs as a single master. So it's important to make sure that blockchain is not acting like a distributed database like Cassandra. Blockchain has nodes, so which prevents from one participant to modify or delete the data added by another. So understand that blockchain is a network. Each node has a capability to store the data, and it cannot be easily tampered because it is immutable. So any good platform will manage networks and thousands of nodes, and everybody is willing to join based on their need, and we can give guaranteed permissions. So here blockchain acts as a platform. It is just not about database. We are not just talking about database. Multi-party aggregation, I just gave an example of database because as a use case for identity solutions or a know your customer. Whereas blockchain enables the entire distributed ledger with which you can store the data across with single node, and you have multiple copies, and it just acts like with a permission way. Anyone can join, and it's completely scalable. So that's what I'm trying to explain in this, how it can help the multi-party aggregation. So see this. You have a hash value, you have a hash chains. So you have a global root hash value. So this is how you call it as a blockchain aggregation. So every data is encrypted. It gets showed as a hash value. And you have a global root hash value. And that too multiple copies. And it gets updated every second. So imagine this. So it's upward downward flow of hash chains. Completely safe, completely immutable, completely tamper proof. So this is what we called as multi-party aggregation using databases move to blockchain aggregation. And it's verifiable electronic data, right? It's a keyless. Basically, it's verified electronic data. That means all the valid transactions, it comes through cryptographic mechanisms and encryption. What more you want? So it offers a beautiful credibility functionality using blockchain. So where are it is? So what all it brings in? It brings in unique digital identity. It is a decentralized infrastructure. It has an ecosystem which is scalable. It is fraud and secure proof. It is automated. It gives you innovation. It's having a lot of data pooling opportunities, and it is technology agnostic. So I'm just reading through, especially insurer. They have this so much of these, blockchain can bring in so much of capabilities. So you digital identity, you can actually do a consideration using a private or a public ledger. It can complement the existing mechanism. It also has data protection. Decentralized, everybody knows. It has a multiple number of nodes. It is self-reliant. It can be used for insurers, brokers, anyone in the system. And it has a ecosystem scalability, right? Because it's peer-to-peer insurance. So this thing which I'm trying to give you, a blockchain aggregation, is for an insurance company. Then it also works as a peer-to-peer. Then it prevents fraud, right? Because it is immutable, right? So DDoS, as we've seen, should be the network should be more than 51% so that he can enter. And it's improved, safe, easier data access to all parties. And it gives automation, right? Because blockchain technology is capable of permitting real-time transaction-based services. Innovative, right? You can actually scale, and you can capture risk mutualization, more sophistication of self-insurance and things like that. Data pooling, anybody can share the data real time, whether it is buyer or a seller or a financial company, it all can, or a claims management or a government, anybody. And then it has a de facto insurance compliance because it is technology agnostic and it suffices all the data protection laws. So if you have opportunities, you have 7 to 8 opportunities, and why you consider blockchain for insurance. So I'm just running through this, basically opportunities for insurance companies and how the consideration, why you need to understand insurance business, especially in the multi-party aggregation as a case study. So it is resilient, right? You can actually have inventory maintenance, detection, respond, and recover. For example, in inventory, it records digital assets. Insurance inventory can be done. You can detect because you can actually have real-time alerting. Respond, you can actually do real-time decision making. And you can recover. In case something happens, you have multiple copies of the data. So you can have a blockchain-based resiliency very easily. So this is one of the biggest use case called multi-party aggregation, and I've shown you what are the advantages blockchain aggregation, and I've given an example of insurance provider why he needs to identify multi-party blockchain for multi-party aggregation, especially insurance industry, given the considerations here, and how does it bring resiliency. Let's end the session here. We will understand how blockchain helps in asset management in the next session. Thank you. Hello. Here we will learn how blockchain helps in asset management. So we have seen like in provenance tracking, in aggregation. Now understand asset management. So this section is actually we are dealing blockchain and asset management. Asset management is the greatest use case in financial services. Let's understand how. So you have business doesn't exert isolation, right? You have customers, your suppliers, your banks, your business networks. Basically, what is wealth? It's a sum total of goods and services, right? And the flow of goods is in the business network is open, closed. So you have a lot of open markets, you have closed markets. So see the networks, right? So completely, most of them currently is a digital asset. And what is wealth? Now we are talking about digital wealth. So what happens? You can transfer assets and you can build value. We have already seen what is an asset. It can be tangible or intangible. It has some value and it can be converted into cash. Cash is an asset. So other asset examples are cars, clothes, bonds, securities. licenses, patent. So it goes on and goes on, right? So basically, you need to have identity, building assets, and transferring assets which has value. So you have participants, you have transaction, you have contracts, right? So we have seen this. Participant is like a business network. It can be like a buyer, seller. It can be government. It can be regulated. Transaction is like when someone sells something to other. And contract is a legal obligation where somebody it is recorded under a statement of record. No? So what happens here? So when in these kind of networks, in these kind of participants, transaction, contracts, you need to have it's all assets, right? So basically, private blockchains offer key benefits. It's real-time asset tracking, it's stable, it is distributed infrastructure, secure, immutable records. So we have seen this in terms of supply chain, we have seen this for provenance, we have seen this for multiple aggregation with insurance as an example. Similarly, for asset management also, this is one of the key things. And blockchain will deliver new efficiencies because you have real-time settlement, you have direct fund subscription and redemption, and it has an enhanced AML, that is anti-money laundering, and KYC, that is know your customer. We have seen this as an example because banks are coming as a conglomeration where each bank is trying to build one ledger. So we have seen if two banks have multi-party, you have becomes 10 banks, it's like quadrupled everything. So if you have a ledger, especially private ledger, it gives you scalability. It's almost like real-time settlements, and you don't have an intermediary at all, and you have an enhanced AML and KYC. So blockchain is in early stages, but it is emerging continuously. And blockchains will directly impact settlement times, fund subscriptions, and redemptions on AML and KYC. We have seen, right, in case of an import and export in a trade finance, like everything is trackable almost on real time. So that means settlement times will come down, subscription will become cheaper, and with all enhanced security and fraudulent detection is faster. So now it's a time for even asset management to identify relevant use cases and develop blockchain strategy. So asset management, like I'm not sure how many trillion dollars are there under assets for any organization in the world. So it's high time for blockchain to identify certain use cases and develop a blockchain strategy. So what is thing? You need to experiment, collaborate, and embrace blockchain technology to win the future. So it's a even in multi-party aggregation, including insurance, is just a small use case. You're talking of asset management, the whole umbrella of financial world comes in. So there should be a huge willingness to embrace. I think we are going towards that. So why again I'm emphasizing because you have a storage ledger, you have a smart contract, you have a network consensus, and you have security. And bottom, it comes with a lower cost, it has increased transparency, it is greater security and faster settlement. So why asset management should go for this? Because it has all the chronological sequences required for all the challenges in the asset management current industry. So what is it? Transactions are broadcasted through the network and it is traveling from one node to another. And distributed ledger storage, it's basically a chronological record of transactions which runs across a business network. All parties agree to a consensus. For example, in the Hyperledger, you can see which are the parties we can agree. Embeds with the smart contract, it's a simple software line of code. Then cryptography is used, encryption is used. SHA-256 example we have seen. And it comes, all the transaction is stored in the distributed ledger technology. And on the bottom down, you have lower cost, increased transparency. We have talked to a great level of how it is compliant. It increases security and faster settlement. So again, some of the blockchain is also getting used for testing, and asset management is using testing. So blockchain technology is moving in terms of the reason why there is a fast-paced tech innovations because there is a lot of blockchain testing experience in Slack. So currently, this is another opportunity area which can be a part of asset management. So where are the things you can do AML KYC testing, and so I've given a simple flow chart how you can do a testing because most of the asset management transparency and compliance is the key. So this is a big opportunity for any company to enter, using AML KYC testing for asset management. I'm just trying to bring this because this has been in some of the conferences, and if you just understand of the blockchain AML KYC testing, this can be easily extrapolated and they can make business out of it. So what happens? The current system is you have a data systems, So all of them lie in the blockchain network. There is a central KYC registry, and then you can do an organization intercheck. So this is a good example of KYC AML on blockchain system. And you have a lot of touch points. This is just example I just try to pull. You have three layers. You have a test layer, which is test delivery. You have test types. You can do blockchain platform testing on Corda, Hyperledger, Ethereum, and you have various test types. The reason I'm trying to bring is KML KYC is catching up very fast. It's already there in the market. So this is one of the key requirements for asset management, and testing is actually lacking. So being a financial services, you can always venture into any kind of thing. You can take it to transaction processing, or you can take assets on blockchain. You can also do shared ledger database testing. So I'm just trying to bring this as an opportunity area, and you can also build capabilities accord. You can do a D app test scenarios. For example, you can create import export app. You can also do blockchain event stream verification. So I'm just giving example, or you can do verification of smart contract and consensus mechanism. So it's a big thing. Basically what you have to do is align, build capabilities. So as a part of asset management, I would like to urge that this is a growing area, and if you can build libraries in the asset management using testing as a part of fintech, this will be a great opportunity area. And these are some of the McKinsey based reports, and this is already very big framework with potential of $100 million. This is just one ABC framework, and basically what I will just want to conclude is this: you can take it as a blockchain as a service for fintech, digital and regulatory information initiatives. You can deliver value, and it's a collaboration between financial organizations, banking, and digital, and all cloud and fintech. So basically, you can take any of them, and why? Because it improves market to time to market. It gives you better business assurance. It convergence between customer centricity and digital strategies, and it gets best improved efficiency and quality. So I just brought it as a part of asset management because there's a very growing area and there's a good need for this. So you can do enhancements, you can do re-architecture, you can create knowledge libraries in asset management, basically on interoperability. So again, some of the examples is like you can do tokenization of assets. That's one example. You can do consensus. You can do secure identification of assets. You can create proof of work, proof of stake for some aligned contracts. You can do auditing of transactions, and you can do anything, right? So basically, you need to develop capabilities, align it with, and you can do any of the bottom down. You can use Ethereum framework, multi-chain, big chain, Factom, Repoler. So basically these are some of the financial based capabilities that you can bring in using testing. So we have seen like in provenance tracking, in aggregation. Now understand asset management. So this section is actually, we are dealing blockchain and asset management. Asset management is the greatest use case in financial services. Let's understand how. So you have business doesn't exist isolation, right? You have customers, your suppliers, your banks, your business networks. Basically, what is wealth? It's a sum total of goods and services, right? And the flow of goods is in the business network is open, closed. So you have a lot of open markets, you have closed markets. So see the networks, right? So completely, most of them currently is a digital asset. And what is wealth? Now we are talking about digital wealth. Here is the end of the session. We will conclude this module with this session. Hope you will get a clear idea about blockchain implementation after completing this module. In the next module, we will cover cross-border payments, smart assets in trade finance, shared trading, smart contracts, online identity in 12 different sessions. See you in next module. Thank you.